Welcome. It's a real pleasure to welcome you to this new Expandeo Day. And today we will start with a specific session on the EU Green Deal as a catalyzer for business opportunities. It's a real pleasure to welcome different people from different industries and markets today. We will have the opportunity to discuss with people from the energy. With the European Green Deal, climate neutral will develop without increasing resource usage. Among the policy areas, clean energy, system Earth observation can support. So, we will have 4 subsections: efficiency, developing new business opportunities. I am delighted to have with us Richard Hyde, principal scientist from sensing and principal technical expert. Earth observation company. This study and the result of this study are still among the most viewed page on the EARSC portal. The oil and gas industry, or nowadays I should say the energy industry, is a very rich and complex one, dealing with exploration and production activities, but as well with shipment in geomarketing. Today, we have the pleasure to have these 2 representatives. Our aim is not to really specifically finger point specific activity from a company, but more to understand the change of this industry, which operates at global scale and deal with science, engineering, and safety. So maybe first I will invite Richard and Tony to say some word about themselves and the scope in this field. Please, Richard.
Yeah, good morning, everybody, and thank you, Emmanuel, and to EARSC for the invitation to talk to you this morning. I'm working in remote sensing in Shell. I started in around 2005. I was fortunate to be involved in the EARSC initiative, which I think started off in about 2014, and I think it's great that we're having this conversation today. There's a lot of good work that's been done, but a lot of opportunity to do more, and I look forward to the conversation. Thank you.
Thank you, Richard. And Tony?
Good morning, everybody. I'm Anthony Credos from Total Energy, the new brand, the former Total. And I'm working for a while also on remote sensing for environment. So I will introduce you some perspective of our company for the next decades.
Thank you, Anthony. So, Richard, as you mentioned, yes, the EARSC has really supported the better connection between the oil and gas industry and service provider with this project EO4OG or OGO. And the database, which provides currently a comprehensive guide to geospatial project using Earth observation.
Opportunity to come together. It facilitated communication. The resource that we have, the oil and gas Earth observation portal that is hosted by EARSC is certainly a tremendously useful resource, but it's also created the opportunity for us to communicate, for us to work together, for us to have conversations like we are this morning. So I think that aspect of the work shouldn't be underestimated in any way. I would say probably in Shell we don't have any unique problems. They're the same challenges that my Anthony would find in I'm sure in Total or in BP or in Equinor or indeed a lot of the national oil and gas companies as well. So bringing together the challenge information from our industry, individual projects are often confidential or have aspects that we find it difficult to share. But bringing together those common problem statements, enabling us to talk together and then understanding what the industry could offer us, what products and services are available from the different service providers out there, how those products and services have been used in some of my peers' companies, and really understanding what the opportunities are. I don't think our problems aren't unique, but they're also there are many ways of solving them. Sometimes Earth observation is part of the solution. Sometimes it's not. So to have clear case studies, as you find on the website, where the business case is walked through, the technology is defined, the technology is described in a way that not just as a technical professional in remote sensing, I can understand it, but it's also portrayed in a way that my colleagues in the different business sectors, in environment, in oil spill response, in new energies, can all understand it as well. So the material, probably I can't spend my days putting together case studies as comprehensively and as well as has been done through the EO for OG initiative. So it enables me to use that material, and I can sit down and have a conversation with somebody, and I've got an example to support that. So if we're talking about the possibility of using remote sensing data to acquire information about shallow water bathymetry, I've got an example I can pull up. If we're talking about oil spill response, I've got an example there. So I find the material it's particularly useful in those internal conversations, material that I wouldn't develop myself. But it also, as I described the importance of communication, integration of remote sensing when we need to work with an external service provider. I don't know. Is that a sufficient answer for you, Emmanuel?
Over the last few years, the oil and gas industry changed a lot. And do you think this database is still accurate on cover your needs, your current needs, current challenge that you have to tackle now?
I don't think it was even comprehensive when it was put together. There will always be a challenge. There will always be a new problem that perhaps we hadn't come across before, or perhaps wasn't a problem that was solved with Earth observation data before. But setting that comment aside, energy's changing. The way we do business is changing. The pressures are changing. There are new business areas that we talk about now that I wouldn't even have imagined back in 2014. So greenhouse gases, tremendously important, both because of targets that have been set externally, like Paris and 2050, but also the targets that our CEOs and our boards set for us to improve the way to become more connected with the environment, to become more connected with the societal targets. Carbon capture, utilization, and storage. Again, not something that we really talked about, sort of nearly 10 years ago. We have much more interest in understanding the natural environment, not least because of the offsetting large areas and the expertise to do that, locating wind farms, solar farms. So there's definitely a play. And of course, the other thing that's changed is EO. Thanks to the success of the European Space Agency's Copernicus program, there is so much more data available, so much more information we can mine from that data. And we have the new tools as well, less desktop image processing and much more use of code, the AI, the machine learning, working in the cloud. So I think there's certainly scope, and I hope there will be enthusiasm from ESA and EARSC and from my industry colleagues and the service sector to update those examples, but also to reflect on those developments in the way we work with those data sets. I think the biggest danger is that we forget the principles, we forget how the fund to get a strong case to do that. Thank you.
Article on just the rebranding that happened recently. I would like to ask a first question to Anthony. There is different way to address the challenge you have to face. The reduction of emissions is the first answer to achieve some KPIs. And could you share with us, for example, what kind of activity you have to in order to reduce the impact of your activities, and how you see currently the impact of Earth observation in this service?
Hello, can you hear me, Emmanuel?
Yes, perfectly.
And I shared my screen, is it okay?
Yes.
Okay, perfect. Thank you very much, Emmanuel, and your initiative to invite us. We are talking today, but we are totally merging on the messages for the energy companies right now. We are not only oil and gas company. Just a few words from my R&D vision to answer your question. We created a project for R&D around Earth observation and artificial intelligence for several purposes in our company. It's called Demeter, and so I totally agree with Richard that today the data, thanks to ESA, thanks to NASA, and so on, the data, the images are not the issue, but maybe how to deal with so much data, how to get the good product for our new questions. And so I've got this first slide to illustrate it. Maybe we can go from left to right and see that on the right, the new businesses we couldn't imagine 5 years ago for an oil and gas company are our reality today, greenhouse gases. And so just for your knowledge, we created this project around the low maturity project for machine learning and deep learning. Which is on the left side, the blue box, and after that we have environmental sustainability around the greenhouse gases and renewables as development strategy, development issues for Earth observation and artificial intelligence. At the end, the idea is to get internal platform workstation to get all these products from Earth observation and artificial intelligence ready for our operation and maybe for our stakeholders also. So just for the technology, as Richard mentioned, so we had the wonderful opportunity to get data from ESA and NASA, for example, and we are contemplating all the technologies from optics to radar to LIDAR. And I think the next revolution is hyperspectral imagery, as we could discuss with Emmanuel some days ago. And the several approaches from satellite until field, and taking the revolution of drone UAV acquisition with higher resolution, spatial resolution, and spectral resolution. Is it answering your question, Emmanuel?
Yes. I think you cover in a way the
for methane and carbon
role of Earth observation
yes,
in order to solve the current impact of your activity. And you already share with us some elements about the upcoming solutions that you are currently developing or working on for R&D. And for sure, we can see that there is topics, thematics that we couldn't imagine a few years ago. I heard and we discussed about forest management before, for example. It's quite impressive to consider that this is an asset that you are working on in order to develop new business. Are you able to share more information on this, for example?
Yeah, as mentioned by Richard, today we are talking about forest management, biodiversity. We are talking about biomass. We didn't talk about water resource, but it's also a key compartment, a key vector for climate and the sustainability of our operations. I think Earth observation has to contemplate this water resource management a lot. Just to focus on two main actions, R&D action we have, and that will be transformed in operation in the next months and years around forest management. We have the ambition as Shell, as Equinor, to go to net zero emission in 2050. So this is a huge effort for energy companies to reach this big ambition. And Earth observation and artificial intelligence is clearly inside the key solution to reach this ambition. We are clearly talking about concrete example of forest we will have to manage from space and maybe from the field also to calibrate our observation. And we are also talking about some new examples of new energy crossing crop yield agriculture with solar energy. This is like a niche. First example we can discuss after, but I want to show that our business is changing a lot in symbiosis with.
We have in the chat. They ask us if there is a plan in EO4OG V2, which would make sense for you. This question to Richard.
I'm not sure it's the focus on OG or indeed on energy is entirely appropriate anymore. There is so much overlap between our goals and objectives and, for example, the United Nations Sustainable Development Goals, a lot of the EO capabilities that are being created to answer other questions are equal.
All the environmental issues we had in the past. I would say that maybe the initiative would be EO for energy and low carbon energy maybe. This is our boss is talking more about that right now, that only oil and gas. We are an energy company and not an oil and gas company anymore.
And you mentioned, both of you, that there is an increased need in the processing in order to develop solutions. Are you involved in Gaia X Energy Domain Working Group? This is one of the questions from Emmanuel Mondo.
For me, that's a simple answer. I'm not familiar with Gaia X. There are many initiatives in this space, and I would struggle to keep.
Great, thank you. And the last question we have, how can Earth observation data and services help your industry to reach these environmental and societal targets? Do you foresee some specific more interest or increase in the use of specific data or services?
You want to take that, Anthony?
I think today, as we mentioned before, the provision of imagery is not the key problem. Maybe in some businesses like monitoring of forest or crops, we would need more spectral resolution and some discussion about tropical forests where we have lots of clouds and we can't see anything in the big part of the year. So UAV, as I mentioned, may be a good intermediate tool to get imagery. And from the side of data treatment, it is a revolution, I think, each day. We are talking about supercomputing in our companies for geosciences in the past, and today putting all these resources, computing resources for HPC, high computing capacities to our Earth observation product will be a key point also. Yes, this is my answer.
Maybe if I can add a couple of things. In the data and services provision, be enormously complex, and just getting commercial agreements in place that enable us to access these capabilities can. And I think the other thing that's really important is validation, whether we're talking about conventional land cover, land use mapping, my own area, methane quantification, having validation of results, having demonstration of what the data are capable of, proven examples, for example, combining different types of sensor to demonstrate consistency of the result is tremendously useful. There's a lot of products in the market at the moment that appear to come from a black box and are perhaps difficult to validate and confirm the value of. So helping us be better customers, demonstrating what the technology can do, would be tremendously helpful.
Thank you very much. So we are already a bit late due to our own technical issue. Thank you very much to Richard and Anthony to have shared their view on the current evolution of the energy industry. And we heard some really interesting message about the potential update we could propose to EARSC in order to be closer to your needs and better understand how this could be fruitful for service provider as well, understanding how this access to data and processing could be easier. Thank you very much. So if you see me on my phone, it's not because I want to see how people are discussing about Expandeo. Even there's a lot of activities, just because I
do I need to share the screen already, or
yes,
please,
which requires me to log between the different sessions. That's all. Yes, I can hear you absolutely. So, welcome to this second part of the session, the Green Deal. We will now discuss about the agro-insurance. Based on medium or high resolution data, agriculture is the second biggest Earth observation market. Used to, for example, monitor crop health, estimate yields. The role of Earth observation in the agriculture market is acknowledged by the European Commission, which encourages member states for the use of Earth observation technology, especially for monitoring in a continuous way the correct payment of all declared area for AIDS. Funded by ESA as a best practice study, EO for high agro-insurance highlight how exactly remote sensing can help to tackle the challenge of agricultural insurance industry. We have the pleasure to have today with us Michael Seelwald from GeoVild and Anseli Lusti from Swiss Insurance. So, Michael, the floor is yours.
Michelle, you can start. In the chat there's thank you.
We can't hear
So I
you.
can present already?
Yes.
Okay. Yeah, hello everyone. Thank you for the opportunity to present in the next minutes our project Earth Observation for Agro-Insurance from best practice to practice. One of our champion users once mentioned that we now have found a common language, a mutual understanding between the Earth observation and the agro-insurance sector. And I think this is key for this project and for future collaborations. I'm happy to give you some insights on what we have learned and done so far. In this project, we as Geoville are working with, together with Vito as partner, and Agro-Insurance International, our partner from Georgia, is, let's say, the link between both worlds. The project is funded by the European Space Agency, who is strongly supporting the activities as well. And we are also supported by EARSC. Most importantly, I'd like to mention that we are accompanied by several champion users from European hail and reinsurers. The basic idea is to connect the agro-insurance sector with the Earth observation sector. And this gives us a chance to find out what are the needs of the agro-insurance sector and to show in return what we as Earth observation industry can do. Remotely sensed data are not yet being used to their full potential for insurances. One bottleneck is the lack of awareness of Earth observation products and services. And for this project, at the very beginning, 3 opportunities were defined to, let's say, exploit the full potential. There was the improvement of existing and available Earth observation technologies for the agro-insurers' needs, raising awareness for further current Earth observation capabilities, which they are often not aware of at the moment, and future Earth observation technologies that are suitable for the agro-insurers' needs. And therefore, our approach was to look in a first step at the needs and requirements of the agro-insurers, and in a further step, match it with already existing Earth observation capabilities and future capabilities to also see where there are some gaps. And in the end, develop a roadmap to follow up on the current activities in the future. To do this, to find out what the agro-insurance sector's needs, challenges and requirements are, we have conducted a lot of activities like presentations, user workshops, surveys, user meetings, where we got in contact with the agro-insurance sector and gained more and deeper insights into their daily life and workflows. A list with more than 60 challenges and needs of the sector were identified, such as the assistance in damage assessment, the identification of potential risk effects, the estimation of affected area and the extent of the damage, also the monitoring of the crop development throughout the season. And these challenges were then translated into geoinformation requirements for a better analysis of currently available and future Earth observation capabilities. And as a next step, we had a deeper look into what Earth observation provides to address these. As could be seen so far, remote sense or the business processes of the insurance industry can be supported by numerous remote sensing products and services. And the outcomes of this analysis can, so the challenges, the requirements, but also the capabilities can be found on our project's website, which is hosted by EARSC on their portal. Based on all our insights, we have identified some key aspects and defined a kind of roadmap. What we've seen is that there is a gap between the perceived potential and the actual uptake. And therefore, it is important to increase the visibility of Earth observation. Also, to enable a better utilization, it is important to provide support, training, and guidance on the products. Another important point is that neither the Earth observation sector nor the agro-insurance sector are a static one. So both industries are developing, and therefore the needs, the challenges, and the capabilities are changing and developing. And that is why we're identifying also opportunities beyond the project's, let's say, baseline focus, and are rehearsing currently the challenges also in the light of the current pandemic. Most importantly, what we have seen is that remote sensing offers opportunities to the many opportunities to the agro-insurance sector. Nevertheless, soon it became clear to us that the available Earth observation products need to be adapted into agro-insurance solutions to fit into the daily workflows of an insurer. And that is why we are currently in the process of designing customized demo cases within the project or the project extension together with the champion users. One use case, for example, should support the loss adjusters in the field. Within a specific radius, the development of the different parcels of the same crop type should be detected and shown on a platform. And the variations between those fields then help the experts in the field to decide on their cases. And we are implementing this also on a demonstration platform to go step by step forward from best practice to practice. With all this information in mind, the challenges of the agro-insurance sector, the capabilities of the Earth observation sector, and also the strong dialogue between both industries. In this project, we are heading from best practice to practice. And I think we're on a good way to find the right, let's say, plug-in in the end with our free demo cases. Earth observation provides a lot of opportunities. Now it is important to enrich these products to make innovative business solutions that fit into the daily workflows and support the daily life or the daily work of the insurers. And with this, I would like to hand over to Hans Süli, who will give some insights on this from an insurer's view.
Yes, thank you very much. Dear participants of this conference, I would like to give you some information from the view of crop insurances. Michaela mentioned that we are hail insurances. That was due to the fact that most of these insurances in Europe has been founded, historically founded as pure hail insurances. But today we are actually crop insurers. Crop insurers means we are covering crops, agricultural crops like maize, corn, cereals, but as well fruit and wine and all other kind of crops against meteorological risks like hail, like floods, like storm, drought, and especially drought, flood, and frost are risks which are becoming more and more or with services provided by Earth observation data providers, we can develop better products because we have information about the field. We have maybe about not only about the crops, but as well about the soils, about temperature, about the climate conditions in the fields, in the regions, in the countries, and therefore we can build or develop products which are adapted to the farmers' needs and the farmers' environmental conditions. But that means as well, this will be a big challenge in the view of acceptance of EO data among the assured. So this is totally new. Normally, you can imagine farmers, they know quite good what kind of crops they are planting, what kind of conditions they have, but for them, it's like a black box, what insurance companies calculate for their what kind of tariffs they do have, what kind of insurance premium they have to pay, and therefore they have, with Earth observation data, they will also have access to more detailed information. So this asymmetrical information, which is actually often the case between insurers and assured persons or assured farms, this gap will be, in the future, will be smaller. And therefore, I'm quite sure that the acceptance will arise. Then some points which we have detected during this project. It's very important to have high temporal and spatial resolution of EO data. Because we are on 1 square kilometer, there are maybe 10 different kinds of soils. There are different kinds of conditions, resolution. So this is one of the biggest challenges or biggest problems which we have detected. We use very good or high resolved EO data. Crop insurers are normally not big companies, so that means crop insurance is very specialized companies are not yet used to use Earth observation data. They have some knowledge. They are building now up the knowledge, but at the end, it's still not decided, or I mean, at the end, it's a decision of every company, but we don't know yet if it's better to build up own knowledge with specialized teams, or if we should buy or let provide us by external companies which are specialized in Earth observation data. So next point, the data availability. I give you an example. You can imagine plants, and they are growing and growing, and in the soil there are less data during this growing process. If they are after harvest, before harvest, and they healing. It's like need actually data without gaps, if possible. So if we have 2 or 3 weeks no data about because they are clouds or satellite services. And as I already mentioned, we are in the middle of a process to build up the know-how, but this will be hard work. So Michaela, please to the next slide. Thank you. But nevertheless, there are huge possibilities with Earth observation data for our business, for our daily workflow. I'm a business of corn, 10 hectares, and with a height of the plants of 3 meters. regions in that field where the plants are broken, where the stems are broken, or maybe they actually have forests of corn plants. And now our loss adjusters, they have to go through the fields. Surfaces are destroyed. If we have images from drones or satellites and images or data where this reach, the loss adjusters get the necessary information directly on their mobile device, that would be a big help. Or another case, we have to compare fields inside a certain circle, inside a certain region, a diameter. We have to compare fields of the same crop because we don't know if everyone in this region is doing his work in the same quality. Maybe he has made an error in the irrigation or in the fertilization, or maybe there are data could help us to, you can see, more efficient and as well where we should. We have this means if we are able to conduct like parametric insurances, they are products. One is the traditional line with loss assessments, with loss adjusters in the field, and they say what kind of damage they have, and then the indemnity is calculated. Or the other line is parametric insurances, where coverage is calculated, coverage and indemnities are calculated only on data. So if a limit is passed, like precipitation or maybe vegetation index data, if there is a kind of limit is passed, and to Matt, if you have any questions.
So please, I invite attendees to use the chat in order to ask their question. I'm sure that a lot of are really interested to understand more, in fact, between this more about this gap between the potential of use. Do you think there is a lack of trust? Do you think it's lack of is the lack of availability of the service at the resolution, which could be temporal or spatial resolution, expected by the farmer, or is it or the insurance company, or is it linked to the trust in the accuracy of the layer that they received or purchased? How can we try to leverage this? It's an open question to Michaela or Answeli. Can they? I'm not muted. Okay. We have is more linked to the data that may not.
Well, it depends a little bit on the situation in the agriculture. In Western Europe, we have lots of well, not in every region, but well, a lot of regions like in Austria, Italia as well. Italy, sorry, France, as well. Some parts in Germany, which are very small structure because of the situation in that field. There, I don't need any information about 1 hectare. There we are talking about square kilometers or square miles of arable land of crops, and I think in under these conditions the actual resolution is already enough. But as I said, that this is about due to the situation in the different regions. I think this gap will be closed, maybe not only by higher resolved data, but as well due to new technologies. We have been shown by other companies, external service providers, with kind of interesting calculations of lower resolved data, and then they recalculated this data on smaller surfaces, smaller areas. So there are possibilities to close this gap.
Thank you. Are you aware or are you involved in the EARSC Agriculture Domain Working Group? If yes, do you foresee a relevant place there for EO stakeholders? Are you aware about EARSC?
Questions?
Yeah. Are you aware of EARSC? EARSC, it's a federated secure data infrastructure which is developed. So maybe there is an opportunity to inform about this. This is a So thank you to both of you for your presentation and your answers. I hope it. I'm sure it has stimulated some people in the attendees interested to promote more what they can deliver to you. So this will end this subsession on the agro-insurance, and we will start really soon with another station on the raw material. Thank you. Close the mic, please. Thank you. Welcome back to this third part of this session on the Green Deal. We will now discuss about the raw material industry. In 2020, the Commission presented its action plan on critical raw materials. As said by Thierry Breton, a number of raw materials are essential for Europe to lead the Green Deal and digital transition and remain the world's first industrial continent. Earth observation with Copernicus, but also commercial data and EO-based services are a key asset to improve resource exploration, operation, and post-closure environmental management. Funded by ESA as a best practice study, EO4RM for raw material identified key challenges of the mining sector and suitable solutions drawing from modern and future Earth observation capability. I'm really happy to have today with us Margaret Van Maal from Deltares and Brendan Morris from LTMS. So please, could you introduce yourself? Margaret?
Thank you very much for your invitation. And I'm happy to be here today. My name is Margreet van Marle. I'm working at Deltares, which is a not-for-profit research institute in the Netherlands. And over the past 1 year and a half, we've performed a project which was called Earth Observation for the Mining of Raw Materials. And we did this together with LTMS, which is today represented by Brendan Morris, and also some other consortia partners, which included S&T and Geophil. This project, EO for Raw Materials, was performed as part of an ESA project, and the goal of the project was to gain more insight in the potential of Earth observation to be used for the raw materials sector. And the real goal was to fully unlock the potential, but that's of course an ambitious goal, so we try to make a step in that direction. I will give you a brief overview of what we've done during the project, which provided consisted of 3 steps. First, there was the gap analysis, including a geoinformation requirements and mature EO technology analysis. Then the second part was based on this analysis to develop surface mockups to see for high potential products what the potential solution could be. And then eventually we also looked into a best practice roadmap. So how can products be taken up by mining more, and how can collaboration be supported better? We supported our results with 2 workshops, one at the beginning of the project to really gather all the data and all the needs. And also there was a workshop at a later stage where we presented our surface mockups and also gathered more needs and information on how to implement this. Our team consisted, besides our consortium, of an international advisory board, which consisted of several mining companies, but also by universities and geological societies in Europe. And for example, Eurogeosurveys and also European Commission and Euromines supported our ambitions, and of course as well EARSC. And who are also so kind to host us today. And we also made our products available via the EARSC platform. To give a brief overview of all the steps we've taken, we started with a gap analysis for the full mining cycle, and we did that by first identifying all geoinformation needs in the mining life cycle, which consisted of exploration, environmental planning and approval, design, construction and operations, and closure and aftercare. And when we know all these geoinformation needs, we were looking for what the specifications were needed. So, for example, the temporal and spatial resolution, refresh rate, etc. And also on the other side, we looked at what kind of technology is already being used, so what is in place and not. And then we compared that with the capabilities of several EO products and identified the utilization gap, the R&D gap, and the guideline gap, which I will explain shortly. All this 60 geoinformation needs were put on the EARSC portal, which I put a screenshot of here. And all challenges can be identified by via the website by viewing all challenges. And for example, for exploration challenges, it's then possible to click on the specific section and gain insight in that. For example, for geochemical mapping, you can see that there are several EO products available that might potentially solve the problem. We then match this with the needs. Well, we match the needs actually with the EO potential. What you can see here are 15 product sheets that are summarized very briefly. And eventually we did for 30 product sheets we added to the EARSC portal. And for every Earth observation product, we made a sheet. So for example, for groundwater monitoring, you can see that there is a picture with an example, but also it gives you all kinds of information. So the description, what possible data is already available, whether it's commercial or open data, and what the specifications really are. And another example, for example, is ground stability, which also gives you a really nice overview and a picture of where to get the data and what is available out there. With all this information, so we have the product sheets and we do have the needs by the mining sector. We were able to score every product, Earth observation product, on their capabilities and their demands. And this way we could make 3 types of gaps. So the utilization gap, the R&D gap, and the guideline gap. And that way you can, for example, see that if there's a high demand, but whether the capability is still low in EO, there's an R&D gap and more research is needed in Earth observation. But if on the other side, if there's a high level of detail already available for Earth observation, but the demand is quite low, there's more of a utilization support needed. Based on that, we could rank all the products. I put 15 in this graph, and this way we could identify where they stand on a relative place in the graph. And based on that, we chose, and this SWOT analysis, we chose 2 products which had a low R&D gap, so they already were quite sophisticated, but had a high EO capability. And based on that, we made 2 use cases, which will be described in more detail by Brendan later on. So one is about the tailings dam stability, making use of radar interferometry in the Cadia mine in Australia, where we tried it and applied it. And another one is based on stockpile monitoring. Based on these results, we also tried to make a roadmap report, and we identified several barriers to fully unlock the EO potential, which might be a nice starting way of starting the discussion later on. In our experiences and what we found in the study was that there was a general unawareness of the potential of EO services and also its business rationales, especially at smaller companies. Furthermore, the availability of the EO services that really provide the tailored information that the mining sector needs, there is also a barrier because sometimes an EO product is available, but then if you need to apply it for a specific problem in the mining sector, it always needs some alterations. So these services, there could be a challenge identified for future developments. Furthermore, there are sometimes, especially when there's high resolution data necessary, the costs of products and services are a barrier. Eventually, there's lack of procurement procedures with commonly accepted terms of reference, and often skilled personnel in EO technology is lacking at mining companies. All in all, that can be concluded then is that to overcome this, we need to think about how to communicate well, how to communicate proven success stories, and really show what the potential and application of EO could be, because it's very large and it would be a waste not to use it.
Okay. Good afternoon. My name is Brendan Morris. I'm a chartered mining engineer. I currently am a managing director of LTMS, a small consultancy company. I'm also the COO for a small mining, gold mining operation in Northern Ireland. And I was very happy to be engaged in the Earth observation for mining project, along with Margate and the other team members. As a follow-up from Margate's presentation, as we say, we identified the mining cycles. The four main areas were exploration, planning and development, operations, and closure and aftercare. And these four areas are very specific to their own needs as well. Some of the areas that have opportunity for Earth observation within exploration are geological and geographic mapping. In the planning and development area, you've got areas such as water catchment, flora and fauna, population, etc. In operations, then we have ground stability, which is well used, water monitoring, and then closure and aftercare. Much work is being done now about with rehabilitation and revegetation. So all of these areas in their own rights, plus many other areas, are important. Important interactions between Earth observation and the mining industry as we know it today. So there are many other areas, but we highlighted three areas in the study, and the first one we highlighted was tailings dam monitoring. There is a lot of technology in place for this. There's a lot of standard technology in place, such as surveys and instrumentation, but Earth observation brings a completely new potential to this, and we'll move on to that in a few minutes. The second area is pit slope stability, and it's similar in a way to tailings dam monitoring, but you know, with some differences. And whilst there's technology in place for that, through surveying and again instrumentation, the Earth observation brings definitely an advantage to this area. The third area we studied was stockpile measurement, and this has huge potential because stockpiles in mining companies, particularly open pits, have to need to be surveyed on either monthly or quarterly basis due to for many reasons, but one of them being financial reasons, so that they can the mining operators can understand the quantities on board. It's a hugely onerous task, takes a lot of time, a lot of effort, and Earth observation has the potential to do that, but we found through our project that this area is not sufficiently developed yet, and needs some further study and needs some new algorithms to be developed to help with that. So that's certainly an area of potential. Next slide, please, Margaret. So if we just talk about tailings dam stability, it's important to know that there's over 3,500 tailings dams worldwide. That's a significant number. A recent study suggests that we have 2 to 3 failures per annum, and that's actually putting about 1.3 million people at risk. And there's been some very significant dam failures recently, with multiple fatalities, particularly 2 in Brazil, but there was one recently in Hungary as well. So there's a lot of potential across the globe for this. One of the interesting things about tailings dams is that many of them are owned by currently active mining companies, but many are not, and many are left to the regulators or the government to manage, and it's hugely problematic in some parts of the world. So huge opportunity here for Earth observation. Monitoring on tailings dams can definitely highlight preventative actions. It can provide early warning of imminent failure, and it really provides a simple system of monitoring in remote areas. There was one area we studied, and that was the Newcrest Cadia gold mine in Australia, where there was a tailings dam failure. Now, we don't have all of the details on the monitoring of that at the time, but we do understand that they were expecting it and they had anticipated it in advance. However, when we did some retroactive EO observation on it, we were able to find that the time scale on the graph up above was able to show that there was movement in the area, and you can see it from the red area of the bottom photograph. You can, the red area highlights the area from the satellites that with the most movement. And you can see that at a certain point in time, which was a few months before the actual failure occurred, the slope of the graph steepened significantly, and this was a very good indication as to what was going to happen. Now, this is the type of technology that certainly can be used by mining companies, but by regulators and by consultancy companies across the globe, and it can serve a purpose to monitor tailings dams in very remote areas very easily over a period of time, and anticipate any potential unwanted events. Next slide, please, Margaret. Next one is pit slope stability. So major safety and production risk for the industry, and there have been a number of fatalities due to pit slope failures across the globe. Pit slopes require continuous monitoring, but a lot of this is now done by using traditional survey techniques, instrumentation, and drones, etc. There's been a number of high-profile failures in recent years, most notably in Bingham Canyon, which is shown in the photograph there. Huge failure. It was anticipated, but again, it shows the high risk involved in this, and again the potential for EO technology to work its magic to help to anticipate this and highlight the need for preventive actions. It can also provide early warning for imminent failure, and it's a good alternative to current monitoring. There is a downside in that the flyover times are usually often around 7 days. That works very well until we get to a point where the failure is imminent and the flyovers aren't frequent enough. That's where the traditional survey techniques and the drones and things come into their own at that stage. Next slide, please. As part of the program, we studied an example of the Scorpion zinc mine in Namibia, and it's a mine that my company LTMS was familiar with. It's part of the Vedanta group, and Vedanta were happy for us to share this. The graph on the right shows the predictability of the failure. It shows that the slope of the line again starts to increase around 2018, and it starts to, you can see at the bottom of the picture, it increases even more in 2019. The red area of the photograph shows the area of greatest movement, and with the benefit of hindsight, where we know that that the monitoring could have identified this failure in advance. We also know that because LTMS were involved in the investigation of the failure afterwards, we know that one of the causes of the failure was the buildup of water, and that the area could have been dewatered prior to the event happening. Now, in hindsight, if ourselves or some other company had been involved in 2018 and we were able to observe the increase in movement in that zone, then a dewatering program could have been put in place, and this pit failure could have been prevented. So it's definitely an area where there's great benefit. Next slide, please, Margaret. So in summary, we can definitely say that EO is being used in some parts of the mining industry. There's no question about that. It has significant potential to increase the use by mining companies, regulators, governments, and consultants. there are major benefits in some areas, but there is a disconnect between suppliers and the mining industry. Our observation and my observation from consulting on a global basis is that the bigger mining houses are reasonably well equipped in this area, but the mid-tier mining companies and the smaller mining companies are not. And so in some cases they have pretty well zero knowledge of the capability of Earth observation. Since the project closed, we've been engaged with a copper mining company, a Canadian copper mining company with mining operations in Brazil. And through engagement with them, we have brought on board one of the teams from the EO4RM project, and we're looking to start up a project of tailings dam monitoring and stockpile monitoring as a part of their program for surface management and failure intervention. So I suppose that's one of the good offtakes from the project. So the disconnect between the suppliers and mining industry offers up a huge opportunity for marketing and education to bridge the gap, and we believe that this gap needs to be bridged in many areas. It needs to be bridged certainly by the suppliers of the EO technology. Mining companies need to engage, but it really needs to start at the bottom level, and the bottom level is when people engaging in the mining industry are being educated. Colleges and schools need to understand more about this, and we believe the providers need to engage at this level so that people coming into the industry are well equipped.
Thank you very much for this presentation. I may have a first remark linked to a question we received. You mentioned the unawareness of the employees of the industry, and at the same time the lack of skills of employees. But I have the feeling that in the 80s, for example, the mining industry was a particularly well-known user of Earth observation and
I can't hear.
You can't hear me. Issue with the sound? They can't hear me. Yes, you can. Yes, can you hear me now? Is it better? Definitely, it's a difficult exercise to organize this virtual event. Yes. Can you hear me now?
Yes.
Yes.
Perfect. Thank you. Difficult exercise to have this virtual event. I have a question which is linked, a remark which is linked to a question we received. I have the feeling that in the 80s, the industry, or mining industry, was a really experienced user of airborne and or Earth observation data. Is it true, and how could we explain that the use of Earth observation is so limited currently?
I think if I can hear your question correctly, you mentioned something about the 80s and Earth observation in the 80s. Okay, I was in the mining industry in the 80s, and it was Earth observation was used for things like photogrammetry, but I'm not aware that it was used by any major companies in terms of some of the scope, like tailings dam monitoring, open pit stability, vegetation. I'm not aware of any of that, and certainly for the companies I work for in Europe and Canada, none of them were involved in that, because I was on the surveying end and the mining engineering end at this stage. So I'm not aware of it, but perhaps some companies were using it.
For sure, you're as the expert. So there is a real interest to really mobilize the community in order to inform. And this is a question we receive. Are you already using a community platform related to EO4RM, enabling all interested parties, stakeholders to communicate, share events, discuss one-to-ones or one-to-many, leverage knowledge, and so on?
Yeah, one way where we try to do that is making use of the EARSC platform. So that way it's a way of communicating, and it's also possible to register there and communicate. We did discuss actually, Brendan, during the project, maybe making some sort of LinkedIn community, but it hasn't started yet as far as I know.
Yeah.
Certainly any of us who are engaged in the project are certainly pushing the opportunity out there, and I know there've been a number of engagements between Sensar and other mining companies, and I'm not sure about GeoVille, but perhaps GeoVille, we were talking to GeoVille in the early stages about setting something up as well, but there's plenty of scope there.
So you see the interest of such a tool or such initiative, yes.
Huge interest and a huge marketing opportunity for the suppliers. Without a doubt, there's a huge opportunity there because it's something that the mining industry can and will embrace very, very well when they understand the potential. I just think at the moment the mining companies don't understand the potential.
Yeah, and also an advantage of such a platform would be that indeed suppliers and demand can be brought together, but also communication can start on, for example, how to interpret the results. So often what we see is that you've got remote sensing specialists who know a lot about the technicalities of the satellite data, and then you've got the mining companies that know a lot about the process of failing, but often there still needs some sort of translation to be made, like people that know how to interpret the results.
Thank you. And we have another question to Brendan. You mentioned flyover time of 7 days is not being sufficient at key times. Are you just referring to Sentinel data, free data, or have you investigated the use of commercial providers?
I suppose what when we talked about flyover potential with some of the users afterwards, I think there's opportunity with some of the commercial providers to shorten the gaps, but in some cases, in some parts of the world, 7 to 10 days seems to be the norm. And whilst that's very useful in terms of long-term monitoring and stability, if you get to a crisis point and something is imminently going to fail, I think then the 7 days perhaps just doesn't work. However, that gap can be filled by traditional methods and instrumentation. So it's not a major drawback, but it's a small limitation.
Okay. I'm sure there is several data resellers or company who can share with you information about how to increase this acquisition time. Thank you very much.
Okay.
So this will end this subsession on raw material, and we will start in a very short period of time with the last session. It's broken. I can't hear me anymore. Thank you to be here for this last subsession on the Green Deal session. Over the last 10 years, the insurance community has shown a growing interest on Earth observation solutions. Insurance companies need to propose global services to assess phenomena and parameters. As complementary of the classic insurance, a recent approach called parametric insurance illustrates these EO-enabled innovative services. In the context of digitalization of the industry, of climate change, Earth observation and insurance communities will have a key role to play. Today, I'm delighted to have with us Laurent Sabatier, co-founder of Skyline Partners, and Christelle Castet, climate risk specialist at AXA Climate. So please introduce yourself to the attendees. Maybe Christelle first.
Hello everyone. Should I start sharing my screen?
Introduce yourself, please.
Okay, hi. So I'm, as you said, a climate risk specialist at AXA Climate, and I'm leading developments and partnerships in the scope of climate risk. So may it be climate change and adaptation, or also alerting and parametric insurance. So very glad to be here.
Hi everyone, so I guess it's my turn. Hi everyone, so I'm Laurent Sabatier. So very happy to be here too. Thank you for letting me speak. So I'm the co-founder and director of Skyline Partners. We are a British insurtech company, and we specialize on index insurance. So index insurance, we will discuss it with Christelle. You know, is not new, but is still, you know, like relatively not known. Like type of insurance. And at Skyline, we specialize on this type of insurance, index and parametric. We built a technology platform which helps us, you know, to create product and structure them and rate them at scale. And we specialize in creating products, you know, for new type of risks. You know, we've got already existing products in agriculture, on heat stress for dairy cows. We got another one for active, you know, like shooters in the US for the cost of violence. And we are also developing some new type of products, you know, for financial institutions impacted by hurricanes and other natural catastrophes. And we are very interested in partnering with Earth observation companies and remote sensing companies, because we see, of course, you know, like with the rise of new data and new services, you know, like a synergy with the creation of new products on the index insurance basis.
Perfect. We will explore this during this session. So, Laurent, insurance is about the risk mitigation, and Skyline Partners, as you mentioned, is developing solutions for renewable energies and agriculture. Could you explain us how Earth observation will influence and impact the capability to mitigate risk?
Well, thank you, Emmanuel. Yes. So actually, we you know, of course, you know, like everyone, you know, like know it, but the risks are constantly changing, and you know, the protection should also, you know, change and adapt. Climate change and the current, you know, COVID and pandemic situation have completely changed, you know, like the dynamics in the provision of certain, and lots of risks are still uncovered. Parametric insurance and index insurance help to cover these gaps, provide solutions, you know, for risks which are intangible, can't even be perceived, but, you know, are still suffered. And using Earth observation and remote sensing companies, you know, like, and data, we can structure these products and make them available to which are suffering these risks. So we really see this type of insurance, you know, helping the risk mitigation, but also the risk transfer. But not only that, it also helps, you know, sometimes to understand the risk better and mitigate it, you know, earlier on. Because, you know, by understanding the risk, knowing it, you can also set up, you know, some risk remediation. You know, you can anticipate, maybe evacuate in time, and you could potentially even protect and provide, you know, some incentive to do that using the index insurance. We'll give more examples afterwards. Because using an index, you can actually pay ahead of the risk, or pay for losses even before they are even perceived. And you can integrate them with the risk mitigation techniques. Very interesting for natural catastrophes, and I think that Christelle will be talking about this, with the solutions at AXA. But we've got also solutions on our side on the agriculture sector. So we are just launching a product in France at the moment on the heat stress for the dairy industry. So it's a risk which is completely uncovered. The dairy producers and the whole dairy supply chain is completely uncovered, and we have launched a product remediating the risk of stress impacting the whole production chain. So you see like yield, production of milk going down, increase in operational costs, margins being impacted. And not only the producers, but also all the supply chain and the processors, like including the yogurt producers. And we use an index which is based on temperature, relative humidity, and others, using remote sensing data and climatic data. We can indemnify risks which were before not covered at all and not protected. On the renewable energy sector, it's also very interesting. Like there are lots of applications on the offshore energy at the moment. Lots of risks, like are affecting the investments in this sector, and all the project owners and the investors get squeezed by the banks if delays are too high. Penalties, are incurred, operational costs are increasing, and ultimately, it could put the height of the waves, the intensity of the wind, combination of all these factors, the currents, depending on the type of vessels which are used to transport the blades, or using cranes, to bring the blades up to the mast, and all these kind of things can be protected via index insurance. And of course, remote sensing, data and satellite imagery is key in the success of this type of solutions.
How do you, how satellite can foster insurance, parametric models, or other insurance service offered today to develop at scale?
Yeah, so actually the rise of data is definitely making all these solutions possible, and satellite, and all the technologies, in satellite, like the launch of constellations or high altitude, or even new technology, like on SAR type, help to create new products and new indexes, at a more frequent level, twice a day, or at least daily, help also to create new products. You can see that on the fire side, for fire detection, using thermic sensors, and higher frequency, can help to detect fires, earlier on, and actually like the increase in geospatial resolution as well of lots of indexes which are used to monitor drought, biomass, and leaf vegetation index, and all the other type of solutions, like we mentioned, like the construction of offshore, platforms. We can also look, at potential, issue on the geopolitical side, index-based, significant, potential of improvements in risk mitigation techniques and risk transfer instruments.
Thank you, Laurent. Christelle, you are
Yes.
working at AXA Climate, so it's one of the largest company in the sector. What is your view on the parametric insurance compared to traditional insurance we are more familiar with?
Yes, thank you. I am sharing right now some slides. I don't know if you can see them. Let me know.
We can.
Okay, good, great. So yes, I wanted to give you a quick introduction about AXA Climate and generally how we use Earth observation for parametric insurance and services. Since I didn't know the level of understanding of the people present, I just give you a quick background on the context and also on parametric insurance. So right now the insurance sector is facing many changes, and because the world we live in is also facing challenges because of climate change and also because of biodiversity losses. We know that we have a fast-growing population, and also lots of people are already forced to move from their location because of climate risks. And because of the increase in their severity and frequency, we'll see a lot more of this phenomenon happening. There is also big threats on ecosystems, and we're very well aware of the fact that we have many locations that are suffering water scarcity already, loss of biodiversity that will impact their services, their functioning, and employees are very well aware of that, and that's why also we are creating some training programs on these topics. So as I mentioned, as an insurer, we have to face these challenges, embrace it, and move from the role of being a stabilizer of the economy, that's our historical role, to becoming a driving force of this transition, so that businesses can become more resilient and face all those challenges in the future. So there is, of course, climate change that is a huge risk, and we had this famous quote from our AXA director saying that a world that is 4 degrees warmer might not be insurable anymore. So we already discussed there is problems related to climate conditions that can affect the supply chains of raw material, disrupt transport, logistic, also can damage infrastructure and physical assets, and also reduce revenues, and you create direct losses or indirect losses due to business interruption. And therefore, AXA Climate is an engaged, what we call ourselves, engaged climate insurer, who's helping both private and public sector face this climate transition. And the activities we have developed is, as I mentioned, training to raise awareness in companies about all these risks and how to adapt to them. We have also services, 24/7 services, alerting services, consulting, and parametric insurance. The choice for parametric insurance is because it's easy. There is no claim needed. I'll mention how it's triggered automatically. It's adjustable and transparent, and also really fast. Also, we choose the business diversification to support this prevention by design with this training and services and consulting. And the sector we work in is the public institution. We are working with all the major reinsurance pools globally. We also focus on agri-food transition and also insurance for this sector, financial institution, and also the industry. So it can be tourism, energy, aquaculture, construction, lots of different industries. So just a word on parametric insurance. You already heard from different speakers that it's you have to choose an index. That's a geophysical index. It can be climate or even geophysical, like earthquakes. So you can choose many different indices, and the threshold that has to be overpassed to have an automatic payout. So it's very transparent. You have to follow this threshold and this index, and when it's reached, you can have the payments within hours. So it's quite fast and transparent. Those are just a few examples of all the sectors we can cover with water level heights. As soon as you have a good indicator that shows basically that's very highly correlated to your risk, then we can cover this field. So lack of wind, snowfall, high and low temperature, excess rainfall, and satellite imagery Earth observation is very good for many reasons, a very good source of data, mainly because it can cover all geographies. So in data scarce region, it's very useful information to have. So just to deep dive in a few examples of parametric insurance, we have, for instance, wildfire protection, where we can look at burn areas and we can correlate, for instance, this amount of burn area with a loss for, let's say, a forestry organization. We have also for agriculture, there are crop production that can be impacted, of course, by and result in financial loss by climate risk. There are obviously very good sources of data locally in some areas, so we can monitor drought, excess rainfall, or frost by looking at, for instance, weather stations. There is also in certain locations good yield data that we can use also to trigger payout, but as I was mentioning, many scarce data region which are not as good with observation, local observation, in situ observation. Satellite data is very useful, looking at NDVI indices, soil moisture, evapotranspiration, and also precipitation data. So for drought protection, just a couple of examples. We can use cumulative rainfall based on satellite data to cover losses. For another drought protection is using soil moisture data from satellite observations to cover also the corn and sunflower producer, for instance. There is also this evapotranspiration index that's correlated with the crop condition that we can use. And just a last example, it's real-time alerting services. I mentioned we have this service that can help drive preparation and resilience to climate risk. It's 24/7, and there is a big need for monitoring and understanding also past historical events, so time series of data from Earth observations. Some example of the risk that we monitor is the wildfire detection, where we can see from MODIS and EARSC these thermal anomalies. There is also precipitation data that we can use in our flood models. We can monitor storms, earthquake, also tsunamis. So I would probably end this presentation by saying that we look for usually good coverage of the data because we have clients worldwide. We are also looking for good resolution, but it depends. The resolution will depend on the client and on its geographical spread as well. We are looking for a good revisit time where we can have information every day, or the sooner the better, I would say. And this is all because we want to be able to reduce what we call basis risk, meaning having detected some false negatives, for instance, or false positive, where we would not have the right amount of payments sent for the insured. So to limit this risk, we have to have the best data quality possible, and that's why we have a team of scientists working with me to try to design the best indices possible.
Thank you. I have a question. First question. You presented this platform. You have all the different solutions. My question is about the way you collect these layers of this information. You have, I think, a team, internal capabilities. What kind of other approach or technical layers you will need to have access to in order to develop your offer? What kind of potential partnership with your service providers you could potentially foresee?
So yeah, I mentioned that we work a lot with time series of data, so that's sometimes can correspond to lots of volume of data. So we do have a team dedicated to downloading, keeping track of all these time series of data. So we use a lot of, for instance, ERA 5 data, and so we managed to have a team that's keeping up with this information and building our own internal tool to go and get this data. But what's important is to be able to have a simple way of accessing and downloading the data, and I think we can work with APIs, for instance. We're quite skilled at using open source data, which is quite important for us to have this kind of open source data because it has to be obviously clear and transparent for the client. So it cannot be something that we cook ourselves in our kitchen. So yeah, using, I would say, tools to download this data and storing them, it's quite important for us.
Laurent, maybe?
Yes, and yes, I was going to add actually. So of course, on all the production and operational aspect, I mean, like the nature of the data is large scale, so you need to be ready for that. But I think what's very interesting, to get from experts in remote sensing and Earth observation is all the processing of the data. Because there are lots of technical issues, like on the processing and on the signal analysis that actually insurers are not expert in. And where I think, we would benefit, from expertise, like in the sector, to get like the analysis of the clouds, for instance, and how clouds can affect, certain indexes. Because we need to have the data available every day at the largest, frequency possible, especially and in time. And if you got some clouds, when the risk happens, we need to be able to solve that. And I think, this is by working with people in the industry, who have this knowledge, can maybe do some post-processing, combined with other data sets, and will be definitely bringing, some added value to the data that the insurance sector will be able to download like anyone on the public open source data. I think what we are interested in is to work with experts, have, like this type of capabilities, know where to find, like the knowledge and the additional data set to improve this data set which are already existing, to really make insurance more precise, more granular, available at any point in time, and anywhere in the world.
And did you identify already some potential main priorities to establish connection with EO service providers?
So, you've seen in Christel's presentation, and I've also insisted on the key sectors, but the key risk, that we see, and the key sectors that we see the most demand from are, agriculture, tourism, construction, and public institutions and financial institutions. Those are definitely the key sectors interested by this. In agriculture, the perils, are the obvious ones. It's drought, fire, hail, frost. All these risks are all monitorable via climatic data, which is derived from satellite imagery, or directly via satellite imagery, or via indexes which are built, on the back of satellite data. And that's definitely a huge interest, for us to structure some index insurance products. On the construction side, all the aspect of climatic, wave, wind also are very interesting. I think, one sector which hasn't really been, monitored yet, and there are lots of applications, using satellite, is also the defense and infrastructure sector. I really think that there will be, some potential, to structure some insurance products on this. On the geopolitical side and all the political risks and all these type of things. I know that people are looking at that. I would, I would love to hear some potential ideas about that.
Maybe I can complement Laura. I completely agree with Laurent's answers. We also see a lot of potential with the new constellation that are going to come in with this potential of seeing through clouds. You mentioned the cloud issue and visible images, but like having access to this radar data that enables us to monitor maybe even flood in real time, that's very exciting for us. So we are keeping an eye on that. I would say that also something that would be useful is to be able to reduce this the limitation of this precipitation data from satellite. There are huge differences from using one type of satellite product to another, and sometimes it's much easier to use ground in situ data, which is a lot of times scarce. So like being able to work on this and limit this uncertainty would like it's something also really useful. But just on top of my head, I think that would be cool.
About this in situ data, we have a remarkable question regarding the reference area yield. Would you be interested in accessing to data from farmers? The EU Data Act to be released by end of 2021 will it be a game changer?
Oh, absolutely. I think the more data we have on the ground, the better we can correlate our indices. So it's like super useful to have as much information as possible. And yes, we're looking forward to it.
Great, thank you. So I want to thank you for all this interesting informations. It was a way to, this session was a way to really connect with these 4 communities and to define potentially future action as well. So I hope you appreciate this session on Green Deal as a catalyzer for business opportunity for Earth observation service providers. We will close this session now, and in 15 minutes, the first session of the afternoon will start. Thank you to our speakers, and happy to see you really soon to go deeper on all these different opportunities. Thank you.